So what did we learn on Friday? Oh, good. We learned a lot. That was an intense lesson where we learned a lot of C words and we dissected sentences, which is weird for math. But we learned about conditionals, counterexamples, converse, inverse, contrapositive. Remember all of that? Yeah, the reasoning stuff. So hopefully you did your homework over the long weekend and that kind of solidified that lesson for you. But let's take a look at this warm-up. A conditional statement is shown below. If all four angles of quadrilateral are right angles, then the quadrilateral is a square. And you're trying to find which one of those is the counterexample. So one thing I want you to remember, for the counterexample, it makes the hypothesis true and the conclusion false. So I want the hypothesis to be true. I want this to be true, and then I want this last part to be false. I want the angles to be right angles, but I don't want it to be a square. So the answer would be A. A is the answer, because A is the one that does have all four angles are right angles. Do you agree? 1, 2, 3, 4. They're all right angles. But A is not a square. It's a rectangle. So A would be a counterexample. No problem. Okay, let's check the answers. Oh, did you see how old I was? Did you solve for X? It's not that exciting. Woo! Okay. Let's check our answers to the homework. And then we will get into today's lesson, which is Algebra Review number 1, solving for X, actually using our calculator possibly. And then we will take a quiz. So check your homework. Slide. And like on 3B, there's more than one answer, right? So that's just an example. Same with 3C. Well, not really, actually. That's the only one. Can I explain 3D? Sure. So 3D says, give me a counterexample. If 3 points are in the same plane, then they're on the same line. So I want 3 points to be coplanar. I want the hypothesis true. Check. I want them to be coplanar, but I do not want them to be collinear. I want them to be coplanar, but not collinear. So there's a picture of 3 points that are coplanar. They're all in plane, I'll name it R. They're all in plane R, but they're not collinear. They're not on the same line. So that's called a counterexample. Yours says 2 points, then that's an old version. Sorry. Last page. 5, 6, and 7. So tonight you're going to spend some time really digging into these words. Inverse, contrapositive, converse, negation, conditional. I'm ready for questions. Let's start with number 2. I was asked about number 2. Write each sentence as a conditional. The definition of a conditional is an if-then statement. So all you're doing is inserting if and then and making the sentence make sense. So if you're asking about number 2, glass objects are fragile. So you would say, to turn that into a conditional, you would say, if an object is glass, then it is fragile. If, then. You would not want to switch the hypothesis and conclusion. You would not want to say, if it's fragile, then it's glass. see what the exact words are. If it is glass, then it is fragile. Okay? So it's just putting an if and a then. You're taking a normal sentence and you're making a conditional with a hypothesis and a conclusion. What else can I go over? You got to ask me questions so I talk about it. This goes. Every time a batter reaches first base, the next batter hits a double. Every time a batter hits a double, the runner on first scores. John reaches first base. John scores. So this is following a logical argument, right? If this happens, then this happens. If this happens, then this happens. If the beginning of that sentence is true, then John would have no choice but to score. We're not wondering if he scores. If those sentences are true, then he scores. So we are following facts, and we are reaching a conclusion. He scores. It's a conclusion based off of facts. So that's why this one would be deductive. You're following facts. Next one. Your brother tells you that Paige called. You have two friends named Paige. You know one of them is in flight on an airplane. You conclude that the other Paige must have been the caller. Once again, you're using logical reasoning, you're using the facts, and you're coming to a conclusion. I don't know, can you use your cell phone in the air now? When we wrote this, you couldn't use your cell phone while in flight. So pretend that you can't. And so that is also deducing, deductive. Okay? The last one says, your mom has cooked lasagna for dinner every Monday night. Tonight is Monday night, so lasagna must be for dinner. This is the only one that's inductive because just because in the past she's cooked dinner every night, tonight has not happened yet. So you're predicting the future. You're following a pattern, ... That's inductive. Your mom might choose to make fajitas instead of lasagna. She might change her mind. Or she might get stuck at work and not be able to cook dinner tonight. And so we don't know. It hasn't happened yet. And so you're inducing. It's inductive. All right, 4A. It gave you a lot of directions on this one. It said, first of all, to write the converse of each conditional. So I'm going to stop there and I'm going to write the converse. If you travel from the United States to Kenya, then you have a passport. The converse is, I'm not going to write every word. If you have a passport, then you traveled from the U.S. to Kenya. You would write every word. I'm just saving time, okay? So that's the conditional. Then I want to determine the truth value of the first one and the truth value of the converse. So let's look at the first one. If you travel from the United States to Kenya, then you have a passport. That truth value is true because they won't let you travel to Kenya without a passport. They won't let you. So that's true. Every time the hypothesis is true, the conclusion is true. Every time you go to Kenya, you're going to need a passport. The converse. If you have a passport, then you're going to Kenya. Well, that's not true. There are a million places that you could go with your passport. You don't have to go from the United States to Kenya. So the original has a truth value of true. The other one, the converse, has a truth value of false. And the counterexample could be you're going to England. That's the counterexample. You just say another country other than Kenya. All right? Okay. Let's close our eyes and transport back to Algebra 1. Ooh, okay, we're back in Algebra 1 now. And I am not your algebra teacher. I'm good at teaching geometry, but I'll do the best I can teaching you algebra. So the whole goal when we're solving for x is a mystery. We're trying to figure out what x is. And the way to figure out what he is to get him all alone. Like put him in the interrogation room so we can figure out who he is. No. So you want to get x all alone. The way to get x all alone is to do the opposite of what's being done to it. So this one is really straightforward. The opposite of -6 is +6. So to move stuff away from x, I'm trying to find a color that works well on here, sorry. We are going to do the opposite of -6, which is +6. And you know the rules. Whatever you do to one side, you must do to the other side. of the equation. If you need to draw this line, if that helps you, you can draw it. These are going to cancel because negative 6 plus 6 is 0. So on the left, you're going to have negative 2x. And on the right, you're going to have 17. Then we need to still do the opposite of what's being done to x, the opposite. The opposite of multiplying by negative 2 is dividing by negative 2. The opposite of multiplying is dividing. So I'm going to divide by negative 2. I'm going to divide by negative 2. These are going to cancel. And we get x equals negative 17 halves. X equals negative 17 halves. Now, I know that this is going to be tough for a lot of you, but in geometry and higher maths as well, we like fractions, we like improper fractions better than mixed fractions, and we like improper fractions better than decimals most of the time. Okay, so I realize that that is negative 8.5. And you would not get it wrong if you put x equals negative 8.5. That is okay. But we like improper fractions better because when we're manipulating them and moving them, it works better for us. So the answer that I like is negative 17 halves. But if you really want to write negative 8.5, that's fine. Okay? One more thing I just want to go over. I want to make sure we're all on the same page on this. Negative 17 halves is the same as negative 17 halves, which is the same as, I just want to make sure we all are okay with that. Whether you put the negative in the numerator, in the denominator, or out front, it's all the same thing. All of those are equal. Now, if you put a negative on the top and the bottom, then it's not equal. That's a different story. They cancel. All right, let's do another one. Oh my goodness, I spy a fraction. And a lot of us are intimidated by fractions. We don't like them. So we are going to get rid of that fraction. The only way to get rid of this 3 in the denominator is to do the opposite. Every time we're going to do the opposite. And the opposite of dividing by 3 is multiplying by 3. So we're going to multiply everything in this whole equation by 3, and then we will no longer be dealing with a fraction. Okay? So let's do it. Negative 8 times 3, negative 24. Negative x times 3, negative 3x. Keep going. 2/3 times 3. Well, the 3's are going to cancel, and you're going to be left with 2. And then one more time. 3 times 2 is 6. So we took that 3, we distributed it, we didn't leave anybody out. Never leave someone out because then you're not being equal, you're not being fair. And now there are no fractions left. So now we can solve this like we would always solve it. We're going to get all of our numbers on one side and we're going to get all of our variables on the other side. So to do that, the first thing I'm going to do is add 24. Cool. What am I left with on the left? Negative 3x. What do I have over here? 2x plus 30. All right. Now we need to move the variable. We need to move the 2x. The opposite of positive 2x is negative 2x. So whatever you do to one side, you must also do to the other. So we've got negative 5x equals 30. Last step, the opposite of multiplying times negative 5 is dividing by negative 5. And x is going to equal negative 6. The other stuff that we've done, you haven't been required to show work because you're just putting always, sometimes, never, or true, false. But when we are doing algebra, make sure you are showing your work so that I can see that it's not just a magical answer that you got to. If it's x over 2, Graham, you would multiply everything by 2. If it's x over 7, you would multiply everything by 7. All right, last one because we don't have time for anything else. When you have a fraction equals a fraction, you're going to do something called cross multiply. So to solve this, we're going to cross multiply, and we're going to make sure that we distribute. So this is 7 times x minus 1 equals 5 times x plus 3. That is called cross multiplying. So then we're going to distribute 7x minus 7 equals 5x plus 15. And then you get to move stuff around. You do the opposite, plus 7. 7x equals 5x plus 22. Subtract your 5x. 2x equals 22. Divide by 2. I know I'm going really quickly. X is 11. I know I did that Speedy Gonzalez style, but we lost some time at the beginning of class, so you need to use the rest of the time to take your quiz.